Okay guys, so today we're going to be dealing with section 5.3, and this is polynomial functions. So we need to first understand what a polynomial is. The word poly means many. So a polynomial is simply many terms. It's just a variable expression. So like here's an example of a polynomial. Let's all right here in this little space, let's jot this down. Let's go with let's say minus 2x squared plus 3x minus 5 plus 4x to the third. How's that? That's a polynomial. That has many terms in it. How many terms does this have? 4. Has 4, right? 4? Yeah. What separates your terms? The addition or subtraction. Okay, so you have 1, 2, 3, 4. 4 terms. 4 terms. Okay, so that's a polynomial. It's simply a variable expression, many terms, right? Of course, there are some polynomials that are short, just one single term. There's some polynomials that are like 9 or 10 terms. But a polynomial is exactly that. It's just a variable expression, and it has terms in it. Let's move on to the next vocab word. Degree. Degree, what is that? It's the highest exponent of a variable or variable expression. So we have this polynomial, this that we all wrote down right here in this empty spot. What's the degree of this polynomial? 3, that's right. 3, yeah, cubed. So let's put degree. Let's put 3. Again, it's the highest exponent. Here's the exponent 2, here's the exponent 1, here's the exponent 3. Obviously, the degree is 3. We're all cool with that vocab word, right? All right. Standard form. We've already dealt with standard form quadratic trinomial functions back when we were graphing parabolas. What was a standard form quadratic trinomial function? It was a x squared plus bx plus c. You guys remember that, right? Yeah. If I asked you to find the vertex, what would you do? Negative b over 2. Yeah, x equals negative b over 2 times a. Okay, we're good. Now, the reason why we called this form standard form is because it's organized with your exponents. It had the highest exponent of 2 first, then the exponent of 1, then your constant term at the very end. That's exactly what a standard form polynomial is, but in this case, we're going to have something that's higher than the power of 2, and you want to put it in order from highest down to smallest. So a standard form is a polynomial written in order from largest exponent down to smallest. So let's go with this example that we jotted down right here. That's definitely not in standard form, right? So what would the standard form of that red polynomial be?
4x to the third.
4x to the third.
Minus 2x squared.
Minus 2x squared. Everything else is in order, huh? Plus 3x minus 5. And this is what we call standard form. Simply rewriting it with your highest exponent term first all the way down to your smallest. This is standard form. It's nice and organized. Let's move on to the next vocab word. Next vocab word says leading coefficient. Well, the word leading, if somebody's leading the race, what's happening? That's the first one out there, right? First place so far. If somebody's leading a parade, they're the first one out in the parade, right? So leading implies the guy that's out in the front, right? Now, the word coefficient, we've used this word before. Coefficient is simply the number that's in front of your variable, right? So if I told you, what's the coefficient of 3x? The coefficient would be 3, right? Coefficient of 5x? Well, the coefficient would be 5. Okay, so the leading coefficient is going to be the number that's out in front of the variable when your polynomial is in standard form. So let me repeat that definition. The coefficient, or the number, of the first term of a polynomial in standard form. So if I told you, let's look at this original one. Here, let me do this. Let me block out this right here. If I tell you, look at this original one, what's the leading coefficient? A lot of people are going to say -2, and that would be wrong. Okay, what's the leading coefficient? +4. Okay, because see, once you write it in order, well, it's highest exponent down to smallest, your leading coefficient is +4. Right, so you guys have this jotted down. Let's write that down. Let's put abbreviation LC, leading coefficient. And what's the leading coefficient? +4. Okay, so we already stated the degree. The highest exponent is 3. We stated the leading coefficient. Once it's in order, now you know that the number out in the front is 4. What else? Let's go to the next vocab word to see what else. constant term. Now, we've already dealt with constant before. If somebody's constantly bugging you, what does that mean? They're always bugging you. They don't change, right? They're just bugging, right? Same thing in math. If you're talking about a constant term, it means that it doesn't change. It doesn't vary. It's the same thing over and over and over. If you have a plus 5 at the end of a variable expression, that plus 5 is your constant term. It's never going to change, right? So what is the, let me get this out of the way. What is the constant term of the example that we have here?
-5.
-5. Everybody write that down, please. Constant is -5. So these are all the different vocab words that we have, and there is, I believe, one question on the final where they tell you to rewrite your polynomial in standard form and then state your leading coefficient, your degree, and your constant term, which is a number out there without a variable. If this 5 had an x, if this 5 right here had an x, it would no longer be a constant term, right?
So if you don't have constants,
If you don't have a number without a variable, then you could say that your constant is 0, right? Good question. Anyway, we've gone over all the vocab words. Let's move on to the next part, classifying polynomials. So everybody, let's go to this first group. Let's box it in. And above, let's put first name. See, the thing is this, polynomials are going to have a first and last name, kind of like we have first and last names. Some of us have middle names, but polynomials are also going to have a first and a last name. The last name comes from this group over here. So box this in, put last name. So the first name is based on the degree. What's the degree again? The highest exponent that you see. So if you're looking at a polynomial, a bunch of terms, right? And you see that the highest exponent is 4, well, the first name is going to be quartic. If you see that the highest exponent is 2, that's going to be a quadratic. If you see the highest exponent is 3, it'll be cubic. If you have just like 5x, then that would mean that the exponent is 1. You would say linear. Okay. The last name is based on the number of terms. Again, the pluses and the minuses are what separate terms. So if you only have one term, that's easy. It's a monomial. After all, mono means 1. If you have 2 terms, that's a binomial. That's easy. Bi means 2, right? Bicycle, 2 tires, right? If you have 3 terms, trinomial, right? Triangle has 3 angles, 3 sides. Trinomial has 3 terms. 4 or more, we just call it polynomial. There's many terms. So we have a first and a last name to each polynomial. So we have, let's say this, go back to this polynomial function that we created up here. What is the first name of this original polynomial up here? Cubic. And the last name, 1, 2, 3, 4 terms. That's right. So if you were to classify it, let's write that down. It would be a cubic polynomial. Cubic because it had the highest power of 3. Last name polynomial because it has 4 terms. And anything that has 4 or more, we just call it a cubic polynomial. I mean, a polynomial. The cubic came from the power of 3. I hope we get that. And down here we have several examples, right? Down here we have several examples. What's the first name of this guy? Quartic. How many terms do we have? Polynomial. So this guy right here is a quartic polynomial. So that is a quartic polynomial. And that it's given to you over here. Quartic polynomial, first and last name. Okay. Which one's a quadratic? The one with the power of 2. So this is your quadratic, and it's 3 terms. So quadratic trinomial would be that one. Okay. This one's power of 3, cubic binomial. Okay. So we have all these vocab words. The more you practice it, the better you'll understand it and be able to use it. If you don't use it, you're going to lose it, right? So let's flip to the back side of these notes. And again, normally I would spend a couple of days on this, but we're going to kind of cram more into this lesson because we are so short on time. So right here, we're going to have this exercise that I want you to do with a partner right now. I tell you to use the f of x function, okay, which is negative 3x squared plus 2x to the third minus 1 to answer the following. They want you to first state the leading coefficient. Then they want you to state the degree and then state the constant. Then they want you to classify f of x, giving it a first and last name based on the notes that we just covered, right? So let's do that right now. I'm going to pause it, give you guys a couple of minutes. Please share your answers with a partner based on the notes we just covered, and we'll continue in a moment. Leading coefficient. A lot of students get to this wrong. They say that the leading coefficient is -3. That's not -3. What's the leading coefficient really? 2. That's right. Now, in order for you to see the leading coefficient, it should be written in standard form. So this is obviously not in the correct form. So even though it doesn't ask for it, it'd be a good idea to rewrite it in standard form. Let's all do that. F of x is really equal to 2x to the third. You want that highest exponent term in front, minus 3x squared, and then minus 1 at the very end. Okay, so again, answering that first one, the leading coefficient, that is 2. The degree? 3, highest exponent, that's right. The constant? -1, right? That value that doesn't change, it's at the very end, that does not have a variable. And now classify this f of x function based on your degree and the number of terms. Cubic trinomial, all right, perfect. Cubic trinomial. All right. So we're going to cover this next section of it, and then we're going to practice with the worksheet. But right now, before even doing this, go to a blank piece of paper in your notebooks, or if not, you can just pay attention, all right? You can just pay attention. It's up to you. I'm going to create a function. I want to call it r of x. Why not? R of x. And let's create, could somebody give me a quadratic binomial. Let's go with the quadratic binomial. Any quadratic binomial.
-2x squared minus 3.
You guys, you want a -2x squared minus 3? Yeah? All right, why not? That's a cubic binomial. A quadratic binomial. That's good. Now, what if, this is a function notation. It says r of x is this. This is just the name of this quadratic binomial that you guys just gave me. What if I told you to do r of, give me a number. 2. What if I told you do r of 2? What does that really mean?
You put
Plug in 2 into the x values of your r of x function. So this is called function notation because the notation, it's so quick to write as opposed to me saying, hey, go to your r of x function, plug in the value of 2, and then simplify it. Instead of saying all that, I could just put r with the 2 in the parentheses. That's what it says, to go to your r of x function, plug in 2, and work it out. So the way to do that would be to first replace your x values, and there's only one x, with parentheses, and then plug in that value of 2 right into those parentheses. Then after that, it's just the correct order of operations. You have exponents first, 2 squared, that's 4. So you really have -2 times 4, then minus 3 at the very end. And of course, -2 times 4, that's -8. 8 minus 3, that is -11. So r of 2 equals -11. We already know that, right? So it gets a little bit more interesting when I ask you to do r of, instead of 2, r of 2x, right? Where we throw in a variable expression in there, okay? So we haven't done this before. We're going to be plugging in variable expressions, in this case a linear monomial. We're plugging it into that quadratic binomial. So we're going to plug in, let's rewrite it first, -2x squared minus 3. And inside the parentheses, we're going to plug in the 2x, okay? So when I do this math, you're going to do exponents first. So you do 2x times 2x. That would give you a 4x squared. And then you bring down the multiplication of -2 and bring down the subtraction of 3. So when you go -2 times 4x squared, that's -8x squared. Bring down that minus 3, and we're done. Cool? So that's what we're doing new today. I could also ask you to ask you that, 5rx. Now what does that really mean? That does not mean 5 times r times x. It means 5 times the function r of x. Okay? So I would take my r of x function, which is -2x squared minus 3, and multiply it by 5. So you'd have 5 times the -2x squared minus 3. And you distribute, you have -10x squared minus 15. So there's all kinds of math that we're going to be doing with a polynomial functions, right? We're going to be plugging in numbers. We're going to be plugging in variables, variable expressions. I might even tell you to multiply that polynomial function by 5 or by 3 or I don't know, whatever I ask. So let's go to this ridiculous question that I have on our notes. If you understand what's going on this one, you'll understand any question on this section. This is like ridiculously complex. Not complex, there's a lot of work, I guess. So what does this say? It says g of c minus 1. So normally we'd have something like g of 5. That would tell us to plug in 5. What are we going to be plugging in right here? C minus 1. So that's going to be a whole ginormous problem on itself, right? And then we have minus 3 times g of 2c. So we're going to be plugging in 2c into the g and getting a polynomial variable expression. And then we're going to be multiplying everything by negative 3. And then we're going to take both answers and combine them all, combining like terms. All right, so I know it's a lot, I apologize. Let's jump right into this. I need to take my g of x function, which is x squared plus 5x minus 6, and I need to plug in this binomial c minus 1. So let's first begin by rewriting it. X squared plus 5x minus 6. And we're only going to be focusing in on this part, plugging in the c minus 1 into the x positions, into these parentheses. So we're going to plug in that c minus 1 right here and right there. So let's focus in or zoom in on this. We'll do the rest later. I'm going to completely ignore the minus 3 times g of 2c. We're going to worry about this later. Right now, let's just focus in on plugging in c minus 1, the binomial, into the g of x function. So right here, it's different because we have a binomial that we're plugging in. You cannot distribute that power. You actually have to write this binomial 2 times, multiply it with itself. So you're going to have a c minus 1 times a c minus 1. And again, you're going to have to write really small. So when we distribute, c times c is c squared, c times negative 1 is negative 1c. Negative 1 times c is another negative 1c. Negative 1 times negative 1 is positive 1. We are combining the middle terms, so we're going to get a final quadratic trinomial of c squared minus 2c plus 1. But that's barely the binomial times itself. We still need to distribute this 5 into the c minus 1. So when we distribute that 5 times c is what? 5c. I'm going to bring down that 5c, put it right here, plus 5c. I'm also going to distribute the 5 times that negative 1. What does that give us? Negative 5. I'm going to bring down that negative 5 right here. And I'm also going to bring down that minus 6. So we had this long polynomial, and we could simplify it by combining like terms. So the c squared, you can't really combine it with anything because there's no other c squares. So you have c squares as the first part of your answer. And then you have minus 2c plus 5c. Well, that's going to be what? 3c. So you have positive 3c. And then we have the 1 minus 5 minus 6. What's that? Minus 10. So ladies and gentlemen, we barely have the g of c minus 1. That's what we barely have so far. We still need to go over here to this part of it and figure out what g of 2c is. And then after you figure out what g of 2c is, you're going to multiply that whole polynomial by negative 3. Okay, so let's first figure out what g of 2c is. So let's go to the g of x function, and let's plug in 2c wherever we have an x. So we have x squared plus 5 times x minus 6. And again, we want to plug in this 2c value. So 2c right in there. Let's do the math. It's a little bit easier because it's a monomial, not a binomial. 2c times 2c is 4c squared. 5 times 2c is 10c. Bring down the minus 6 at the very end. And so far, we just have this g of 2c. That's g of 2c right there. We still need to multiply it by a minus 3. So we really have this minus 3 that we need to distribute into that whole thing. You could use parentheses or you could use brackets. It's the same deal. Now let's distribute that minus 3. Minus 3 times 4c, that's a minus 12c squared, minus 3 times positive 10c, that's negative 30c, and minus 3 times negative 6 plus 18. Now that we have this answer right here in red and this over here in blue, now we could combine both. So we're going to begin with the c squares, the highest exponent term. So what is c squared minus 12c squared? Minus 11c squared. Thank you. And then how about 3c minus 30c? There you go. And last but not least, that minus 10 with the plus 18. Plus 8. That's the entire answer right there. Now, just for funsies, what's the degree of this guy? 2. What's the constant? 8. What's the leading coefficient? Negative 11. What's the first and last name of this polynomial? Quadratic trinomial. Okay, guys, so let's look at the worksheet, which is going to be way easier than that last problem. Again, I just gave you that complicated problem so everything else seems easy. So on this worksheet, the first part, they want you to take your p of x function and plug in a negative 2, get an answer. And then after that, plug in a 3 and then get a separate answer. So you're going to get 2 answers for this first part. They're all p of x functions, so they want you to plug in a negative 2 and a positive 3. We are only doing questions 7, 8, and 9. Okay? I mean, you could do more, but on the assignment back there, it's just 7, 8, and 9. Which one would you like to see? Would you like to see any of them? 9? Okay. So let's do number 9. They want us to do both p of negative 2 and also p of 3. I'm just going to do one of them because, I mean, it's the same thing. Let's do p of negative 2, but you need to do both, right? So p of negative 2, what does that mean? You're going to plug in the negative 2 wherever your x's are at. So let's first rewrite it as x to the 4th plus 1/2 x to the 3rd minus 1/2 x. So we're replacing the x with parentheses. That way we could easily plug in this negative 2 right in there. So negative 2 right in there, negative 2 right there, and negative 2 right there. And then it's just a question of doing the math, right? PEMDAS, what's the first thing you do? Exponents. So you have negative 2 to the 4th power. That's really negative 2 times negative 2, that's 4, times negative 2, that's negative 8, times negative 2, that's positive 16. Everybody with me? So that is a positive 16. Now after that, you're going to do negative 2 to the 3rd power. That's really a negative 2 times a negative 2, which is positive 4, times a negative 2, which is a negative 8. So what we really have is a 1/2 times a negative 8. So what's 1/2 of negative 8? Negative 4. So you really have 16 with the negative 4, 16 minus 4. And then at the very end, a negative times a negative is a positive. And what is 1/2 times 2? 1, right? So you really have a positive 1 over here at the very end. So what's 16 take away 4? That's 12 plus 1. That is 13. So I guess you should write your answer. P of negative 2 equals 13. They also want you to do P of 3. So go back and do the same thing. Plug in 3, get an answer. You're done. It gets fun down here on the second part where I give you 2 functions, a p of x function and an r of x function. They're just the names. That way you know which one to use. On number 11, you're using the p function. On number 12, you're using the r function. And instead of plugging in numbers like negative 2 or positive 3, we're actually plugging in variable expressions. You're going to plug in an 8a into the p function. You're going to plug in an a squared into the r function. So on these, I do want you to be very careful, show your work, check your answers on the back. Which one would you like to see, 11 through 16? Pick one. 16. Why not? Let's go for the hardest one, right? So which function am I using, the p of x function or the r of x function? P of x. And what am I plugging in?
X plus 2.
That's right, the binomial x plus 2. So what's that p of x function? That p of x function is 3x squared minus 4. So let's first start by plugging in the x plus 2 into the p of x function. I already forgot what it is. Could somebody read it to me? What's the p of x function? 3x squared minus what? 4. All right. So why did I put parentheses? Because that's where I'm going to be plugging in my x plus 2. Now at the very end, once I plug in my x plus 2 and I get a polynomial, then I'm going to multiply the 5 by whatever polynomial I have. So the first part is plugging in x plus 2 right into those parentheses in the p of x function. So what do we do first? Multiply exponents or subtract? multiply, right? Oh, no, exponents, which is going to be a multiplication problem. So let's do this binomial times itself. So we're going to have x plus 2 times x plus 2. And when you distribute x times x, x squared, x times 2, 2x, 2 times x, another 2x, 2 times 2 is 4. So this is just the binomial times itself. Combine like terms and you will end up with x squared plus 4x plus 4. Now we still have the multiplication of 3 that's out here in the front. So I want to put this in parentheses or brackets, put that multiplication of 3 out there in the front. I'm also going to bring down the subtraction of 4. So I've already dealt with exponents. Now I'm going to deal with multiplication by distributing. So 3 times x squared, that's 3x squared. 3 times 4x, that's 12x. 3 times 4 is 12. And then bring down the minus 4. And you can now combine the 12 minus 4, and we get what? 3x squared plus 12x plus 8. Now that's not the answer. Why not? Because that's barely the p of x plus 2. We plugged in x plus 2, we did all the math, and that's what we got as an answer. We still have the multiplication of 5 that's out in the front. So you're going to take that whole thing, put the multiplication of 5 out in front, and this will be your final answer right here. Your final answer is 15x squared plus 60x plus 40. Somebody check the back for me. Make sure that that's correct, number 16. Yeah. Excellent. So that's as hard as it gets, guys. I do want you to practice this whole thing. You have the rest of the class to do it. It's not much time. I know it was a long lesson. I apologize. But we do want to practice this tonight. Tomorrow we are going to move on to talking about polynomial functions and the end behavior of their graphs. That's a pretty funky looking graph. But just by looking at it, I already know that it's going to be a power of 4 and that the value, the leading coefficient, is positive because it's opening up. But that's all fun stuff that we're going to talk about tomorrow. Okay. Right now, let's work on this. Let's check our answers. Good luck.